Good morning, geometry class. We're going to take a look at 10.5C, our guided practice problems, where we're using relationships of angles inside and outside of circles, part 2. So we're going to take a look first at the one theorem that we're going to be focusing on today, and that's theorem 10.13, where we're looking at angles outside a circle and their relationships with the arcs that they intercept. So on that first diagram, you're going to notice that we have a secant and a tangent ray. Here's our secant ray, here's our tangent ray, and it's going to intercept the blue and the red arc. And to figure out the measurement of this angle 1 here, what we're going to need to do is find the difference between the number of degrees for arc BC and arc AC. So here I am subtracting, finding the difference between arc BC and arc AC, and then I'm going to take half that quantity, and that will give me the measurement of angle 1. And in fact, we're going to use this process for all 3 of these diagrams, finding that outside angle. So this was the case for a secant and a tangent ray, and how to find that outside angle, but it will be the same if we have 2 tangent rays. On our circle here, we'll still find the difference between the red arc and the blue arc. We'll subtract them, so the measurement of arc PQR minus the measurement of arc PR, and then we'll take half that quantity, and that will give us the angle outside that circle as well. Same thing here if we have 2 secant rays. Then to find the measurement of this little angle 3 here, we're going to subtract the number of degrees of the red and the blue arcs, so the measurement of XY minus the measurement of WZ, the number of degrees of difference, and we'll take half that amount and it will give us the measure of angle 3. So notice that all of these ways of finding that outside angle are all similar, whether it's tangent rays or secant rays that are intercepting arcs of the circle. It's always the difference of the further away arc minus the closer away arc, and half that quantity will give you that angle outside the circle. All right, let's take a look at a couple of problems so that you can proceed with the homework problems independently. Example 3 asks us to find out what is the value of x. In other words, what is the measurement of this outside angle? Well, we're going to use that theorem that we were just looking at. We're going to find the difference between this arc here and this arc here, and that will give us the quantity that we need. As long as we take half of that difference, we'll find the measurement of this outside angle. So x is equal to 1/2 times 178, that's our outside arc, minus our inside arc here, 76, and the difference between 178 and 76 is 102, and half of that amount is 51. So we're always going to find the difference of the intercepted arcs, and then we will calculate half of that quantity, and that will give us that outside angle. Guided Practice 5, which will be our last guided practice problem today, asks us not what's the measurement of this outside angle. They tell us it's 30 degrees. But our job is to find what is the number of degrees of this intercepted arc. What is the measurement of A? Well, we're still going to use the same relationship. That outside angle, 30 degrees, is equal to half of the difference of the intercepted arcs. So we're going to subtract A minus 44, the difference of those intercepted arcs, find half that quantity, and that's going to be equal to that outside angle 30. Okay, now we're going to solve for A. So we're going to multiply both sides by 2/1, or just 2, and that will give us 60 equals A minus 44, since the 2/1 and the 1/2 cancel out. We'll add 44 to both sides of our equation. That will give us 104 equals A, and so now we know that the intercepted arc that was labeled A is 104 degrees. So this A degrees here is 144. 144 minus 44 divided by 2 gives us that 30 degrees. Okay, so that's all of our guided practice problems today for this lesson, and now it's time for you to go ahead and move on into the homework phase of this lesson, and we'll see you later.